Hello, Algebra 1 students. This lesson is a video, or this video is for lesson 5.1. Now, in your note packet that you picked up, we have an introduction here of graphing lines. I'm not going to go over this in the video, but I do encourage you to do this. This is review from chapter 4. So you really should be able to do this kind of a warm-up on their own. But what I want you to flip past these pages, and I want you to start on page 4. And this is what it looks like at the top of your page. Okay, so I'll give you a minute to find your way there. What we are talking about in chapter 5, the whole chapter, is what we call a systems of linear equations. So that's what we're defining right here. Now, all this means is 2 or more lines graphed on a coordinate grid. So 2 or more linear equations is the definition here. 2 or more linear equations is what we call a system of equations or a system of linear equations. Remember, if you need to pause the video to have time to write, please do that. These are all systems of equations, so right, it's not a big deal. It's just graphing 2 lines on a coordinate plane. Okay. Then the other big important thing for chapter 5 is finding what we call the solution for a system of linear equations. So that is an ordered pair, which, O-D-E-R-E-D, yes, ordered pair, sorry, that's a little messy, which is a coordinate point that is true for each equation. That is true for each equation. Okay, so I want you to just draw a little picture of what we're talking about here. We're just going to draw a little tiny coordinate grid. We're going to pretend we graphed a line and we graphed another line. This point right here, which I'm just going to call 3, 4, just kind of making this up, doesn't matter if it's exact, that is a solution. So another way to think about it is a solution is the point where the 2 lines cross, or the point that the 2 lines have in common. Both of these lines have this point in common, or the point that they intersect at. So this is what we're doing all throughout chapter 5 is finding that point where the 2 lines intersect. 5.1 is doing it by graphing. So these are the steps we're going to use. Solving, so finding that solution, a system of linear equations by graphing. Well, the first thing you're going to do is graph the 2 lines in the same coordinate plane. Then you're going to figure out where do they intersect. And then check the point from step 2 by substituting it into the original equation. So we can check our answer here. Remember, before we graph, we like our equations to be in slope-intercept form. So y all by itself equals mx plus b, or like I like to say, y all by itself and equal to stuff. The number in front of the x will be your slope. The number hanging off the end will be your y-intercept. And so just a little review of graphing there. Okay, now example 1 says, use the graph to solve the system. In exercises 7 through 9, use the graph to solve the system of equations. So we want to find that coordinate point where the 2 lines intersect. And then it says, check your solution. So here's my 2 lines. They already graphed them for me. There is the coordinate point where they intersect. To get to that point, I went over 2, and then I went, so over 2 and down 2. So x is 2, y is negative 2. So the solution here is 2, negative 2. We're not going to check all these. I'm actually going to check number 3 because we have a little room over on the right to check. Okay, the solution to this system of linear equations is the point where they intersect, which is that point right there, which this is over -1. So my x is -1, and then I went down 1, 2, 3, and my y is also negative. I went to the left and down. So this solution, oops, spelled it wrong. This solution is -1, -3. Okay, one more. To get to this solution, I went to the right 4 and up 2. So the solution is 4, 2. Now, if I were to check this one, I would go to my equations here. I'm going to zoom in a little bit here. Where the x is, I would put a 4. Where the y is, I would substitute in my 2, and then I would see if I get 8. So I'm going to throw out the x and put in a 4. So instead of x plus 2y, it would be x plus 2. And then when I get to the y, I'm going to throw out the y and put in a 2. And remember, I'm checking to see if it equals 8. Order of operations says multiply first, so do this multiplication. 2 times 2 is 4. So I have 4 plus 4. Does that equal 8? Yes, 8 equals 8. So that is a solution. You have to check it on both equations. So let's do the same thing here. Let's throw out the x here and put a 4, and throw out the y here and put a 2. So instead of 3x, I would have 3 times 4. Oops, that should be a minus. Minus 2 instead of the y. Let's put a 2 in there. And again, we're checking to see if we get 8. 3 times 4 is 12, minus 2 times 2 is 4. 12 minus 4 is 8. 8 equals 8. So yes, that solution checks out. So that's what it means by check your solution. Okay, just like when we were solving equations in chapter 1 and chapter 2, sometimes you have these weird situations where you have infinite or no solutions. You'll have that same thing here. This picture, it's hard to tell, but this is actually 2 lines graphed right on top of each other. So if you end up having 2 lines on top of each other, how many points do they have in common, or how many points do they intersect at? All the points. So this is infinite solutions. This actually ends up to be the same line twice. These 2 lines are parallel lines. Parallel lines never cross. So they never have a point where they intersect. So when we have parallel lines, we would say that is a no solution. Oops, you can't see that. Sorry, parallel lines. All right, let's look at example 2. So this one says solve the system by graphing. Sorry, the page break got a little messed up here. So the problem is actually on the next page. So we are going to solve these by graphing. So we're going to graph both these lines and then see the point where they intersect. Okay, so the first line, I think I might graph these in different colors. Hang on, just getting a different color here. So the first one here, y-intercept is 3, and the slope here is -1. So missing a run, add a 1. So I'm going to go down 1 and to the right 1. Remember, this is my rise, this is my run, all that great stuff you learned in chapter 3 and chapter 4. Okay, so y-intercept is 3. So on the y-axis, put your first point at 3. And from that point, we're going to go down 1 over 1, down 1 over 1, down 1 over 1. I want you to put a few points on this, and your lines have to be really, really, really good because we have to find the single point where these 2 lines intersect. I could put some more points over here. I just do the opposite. I go left and up. Okay, now you need to draw a very good line here. Okay, we're going to graph both these lines on the same coordinate plane. This line, which I'm going to do in pencil here, that's the y-intercept. is 5. The slope is 1. It's that invisible 1. So m equals 1 over 1. So this one I'm going to rise up 1 and go to the right 1. Remember, we always go to the right. Okay, so y-intercept is at 5. 1, 2, 3, 4, 5. And I'm going to go up 1 over 1. Oh, I ran out of coordinate grid. Let's do the opposite. Up and to the right. If I want some points over here, I'm going to go down and to the left. So that will be a point on my line, down and to the left. Okay, I don't really need to do much more because I can already see where those lines are going to cross. Right there is the solution. That coordinate point is where the two lines intersect. So that is over -1 and up 1, 2, 3, 4. So down here where it says what is your solution, -1, 4. Okay, let's try another one. These examples that we're doing here, they're all in slope-intercept form, which is great. But remember, if they weren't in the form y equals mx plus b, that would be our first step. Okay, this one, our y-intercept is 2, and our slope is 1 over 2. That's a positive slope. So we're going to rise 1 and run 2. Start with the y-intercept. Put your first point at 2. From that point, rise 1, run 2. Do a few points. Do it again. Rise 1, run 2. I'm going to do the opposite. Down and to the left. Okay, hopefully that's enough points. Draw a very straight line. No messy lines here, or you won't be able to find that point where they intersect. Second line, y-intercept is 4, which is right there. This one, my slope is -1 over 2. So I'm going to go down and to the right. Down 1 to the right 2. So down 1 to the right 2. Oh, look at that. Winner, winner, chicken dinner. I already found out where they intersect. Boom, right there. That was nice. So that coordinate point is over 2. X is 2. Up 1, 2, 3. Y is 3. So the solution to that is 2, 3. Remember to pause the video if you need to, but make sure you have these problems beautifully in your notes. Okay, then the next two are your turn. So you are going to try those on your own. I'm not going to show you the solution to these in the videos. Perhaps I might go over these tomorrow in class, but I will give you the solution. So the solution that you should get for this one is 1, 4. And the solution that you should get for this one, ooh, I didn't do this one. I will figure it out really quick for you. Actually, I won't figure it out really quick for you. We'll just go over the answer to this one in class. I'll let you give me the answer to this one in class. The one thing I want to tell you about here, and I have a hint, it says rewrite in slope-intercept form. Now this one, hopefully you recognize this one. It doesn't have an X or a Y. It just has a Y. So that's your Hoy or your Vux. I'll give you a little hint on this. That's going to be your Hoy. This one, you're going to need to rewrite over here. And then you want to do algebra to get that y by itself. So remember, when you're done, you want y all by itself, everything else over here. Then find your y-intercept and your slope, and then graph it. Okay, now, after you finish these your turns, if you're feeling really good about this, go ahead and try the exit ticket that's on the next page.